Good morning everybody. Today's lecture is based on progressive cavity pump as an artificial lift. PCP, we know this is a high viscosity pump. When you have heavy oil, you have toothpaste, you have grease, you have food processing industry like your pulp is there and you are pumping and you are filling some tube, that time you can use PCP. And some basic background of PCP and pumps has been given already by Dr. Mrinal in previous lecture. In this lecture, I will try to elaborate further of PCP. So, PCP, use of PCP like thin fluid, normally we do not try to pump using PCP, but thick fluid, if you have thick fluid like I already told pulp, you have toothpaste, grease, you can pump using PCP. Next thing is that metering application. Metering application means like PCP will have rotation, rotor rotation. So, each rotation it will give certain fixed amount of fluid. So, if we can control the rotation, actually you can use it as a metering pump, a fixed amount of fluid we can deliver after fixed amount of rotation. So, if we change rotation, volume flow will be changing. So, it can be used as a metering pump. Some other application, I have one patent actually. So, that patent is related to human blood flow application. So, that blood flow application they liked the patent because they wanted to get some pump for LVAD, left ventricular assistive device design, where the blood cells, red blood cells, white blood cells, platelets, all this should not get shared and broken. For example, if you have cell and centrifugal pump you are using, the particle will be getting so much passing through so much turbulent environment that that particle can be destroyed. So, PCP actually takes fixed amount of fluid, it will be transferring progressive cavity pump. The term says progressing cavity. So, one cavity will be there. So, cavity will be rotating and progressing. So, it will not give any shearing action to the cells. So, it can be used for human blood applications, blood flow applications. Also, so there are many other applications also there, but normally thick fluid, high viscosity fluid, metering pump, there you are using PCP. So, PCP as an artificial lift, it is also not very, it is also very newer use actually. If you see 50-60 years back, people started using, and the original PCP was developed by Moino, one still Moino pump company is there. So, Moino, he was doing PhD thesis and by mistake he developed this pump. So, sometime mistake also creates a new innovation. So, it is his mistake actually. So, that is why he developed pump. Now, I have one example PCP here. I think you will see this is stator, this is rotor. So, already Mrinal has explained that rotor will have helical shape. Okay. This is single screw PCP, single lobe is there. So, this is rotor, this will be normal conventional PCP, it will be completely metal, and if I have metal PCP or other PCP, then story will be different, I will explain later. So, conventional PCP, it is completely metal and it will be having helical shape. If you can see this one, it is having helical shape, right. So, you can see this one, okay, I am drawing red color thing, you can see this is helix, okay, and pitch is distance between this one and this one. You see two red lines, one red line is here, one red line is here, okay. So, pitch is distance between two. So, one whole turn is giving one pitch. Now, this is rotor, rotor will be rotating continuously, right. Now, I have stator. Stator is that it is not rotating, that is why stator, it have to fix from like this and you have to rotate this one, okay, and when you are rotating it will enter here, okay. And rotor, stator also is having helical cavity. How helical? If you see properly, here the helix are there, I am drawing, I think, I hope you can see from there, here I am drawing helical thing, then here I am drawing helical thing, the red mark area, this helical, okay. This is coming like this, this is coming like this, okay, and there will be two helix actually here, okay. Now, one pitch is there, okay, one upper portion, another upper portion, ridge, valley, ridge. So, ridge distance is one pitch. Now, stator also will have, from outside also most probably you can see this some red color is coming. Okay, it is like this. Okay, and this red is going like this. Okay, so rotor also helical, stator also helical. Okay, so you can see these two lines are coming. This is also stator, also helical shapes are there. Now, if I put this one, like you can assume like this one nut and bolt. Okay, this is bolt, this is nut, and you are giving rotation. But in nut and bolt, the pitch of nut and bolt will be same. Okay, if we do not put nut and bolt pitch same, then actually nut and nut will not enter into the bolt cavity. In this case, we do not keep same pitch, because if we keep same pitch, then cavity will not be created. So, if we have different pitch, that is why you have cavity actually. You see this. Okay, you see this, I put my rotor, this circular cross section. Now, I have stator is having cavity, but cavity is not circular, you can see it is not circular cavity, it is not actually circular cavity. Okay, it is not circular cavity, it is having like oval shaped. I am drawing here how this cavity look like. Okay, you see this screen, this cavity will look like this. Okay, now this is circular, this one end, and this is not circular, this is like oval shaped, not exactly oval, but I am assuming approximating. Now, if I rotate it, if you see properly, if I rotate it, let us say rotate, you see this rotor end is moving, let us say this is one end of stator, this is another end of stator. Okay, now if I rotate it, just simple rotation. Okay, so rotation, you see this rotor is moving actually up and down. Okay, so you see the screen now. So rotor is there. If I rotate it in one direction, rotors will be moving to another end. Okay, so rotor will be having. Okay, so rotor will be moving from top. This is gap now, and if I rotate here, you see gap changed. So this cavity, actually this cavity is moving from here, here like this. Okay, and this side got broken, this broken side looks better actually. If I rotate it like this one, cavity, rotor cavity, stator cavity, this rotor circular, stator cavity, rotor have circular cross section. Now if I rotate it, you see the rotor is moving up, and if you see properly, there is one gap actually. Okay, this is one gap, this my finger is going now, you see. Okay, you see my finger is going here. Okay, now if I rotate it, this gap is moved actually, this is cavity. Okay, so again I moved this rotor like this, there is no gap now. Okay, again if I rotate, gap is created. Slowly my finger is not going, but if I move further, now my finger is going. Okay, that means this gap is created, gap is going like this, ending here, again another gap will be there. So small gap, moving, gap or this cavity, the name you see this cavity. So cavity is moving. Okay, that's why it is progressive cavity, cavity is progressing. Now you take any fluid, water, you take any grease, toothpaste, your heavy oil, Canadian sand oil, anything you put there, you move it, this cavity will be moving. Okay, cavity will be rotating like this and moving. I have one figure, I'll show. Yeah, here you see one picture I have taken. Here, these are cavities. You can see this green color. Okay, this cavity is moving. This is taken from Wikimedia. Cavity is moving. How is cavity moving? When rotor is rotating, cavity is moving and moving and moving and moving and moving. Okay, so here also, if I rotate it, you see my model. Okay, so how did I get this model? Actually, we prepared this one. One of my master student, he was trying to do some design and optimization work. So we are trying to design using CAD model. Then we found that CAD software is having helix, that's the option, that one it did not work. So, we created lots of planes, we created small planes, then plane we connected using lofting option, then we manufactured using 3D rapid prototyping. This is called rapid prototyping. Within 24 hours they manufactured it. Okay. So, these days industries are using the rapid prototyping machines, or even academic institutions also they are using lots of rapid prototype using one machine. So, quickly they can manufacture. Okay. Okay. Now, this is the PCP. I will explain again regarding that leakage. I think Mrinal has given already some explanation regarding leakage. So, you can see my cavity is here. I said like one finger is going, my like small finger is going here, the index finger is going here. Okay. Now, finger is going, but finger is having two sealing line. Okay. So, one cavity is there, but cavity is sealed like this. Okay. One line is there, one line is there. So, it is creating proper cavity, hole is not cavity. Okay. So, small cavity is here, another cavity is here, one cavity here, another cavity here. So, one cavity, that means two seal line will be there. So, that you are blocking this and creating small cavity, and seal line if not sealing properly, rotor and stator, then there will be leakage. Let us say this is low pressure end, your PCP is like this, your fluid is sucked from here and you are rotating continuously, fluid is getting delivered. So, that means low pressure here, high pressure here. So, what will happen, you are trying to create high pressure, but fluid will try to leak back towards this intake area. Okay. When it is trying to coming back to intake area, it will come through the sealing leakage. So, how the sealing is occurring, I will explain later. Okay. So, I will show it again. So, let us see this one first. So, whenever you are thinking about PCP as an artificial lift, so you will have one downhole or subsurface unit, one will have upper unit or subsurface unit. So, in surface unit, what you have one prime mover. Okay. This is prime mover or motor normally, or it can have some other type of drive system also. Normally, it will have one electric motor. So, one will be wellhead drive unit. So, there will be one polish rod will be there, one will be packer will be not packer, this is called stuffing box. Stuffing box will be there. So, before stuffing box you will have flow line, okay, T joint will be there. Then this is actually wellhead, where through wellhead you can access your wellbore. Then your whatever prime mover is giving power, that will be coming through your gear and or belt drive. Why gear or belt drive is required? Actually, PCP speed, normally PCP speed is 300 RPM. This is thumb rule. You have, if no information given, you can assume 300 RPM PCP speed. So, 100 RPM, 500 RPM also possible, but more than 500 normally will not be available. But people are trying to design newer type of PCP which will have more than 500 RPM, but normal use 300 will be optimal. Now, when you have PCP speed 300 and motor speed, let us say 1400 or 3000 RPM or 3600 RPM, that means you have to reduce the speed. How to reduce? One option is there, you can use VFD and you can change electrical frequency, then reduce motor speed. So, that is also create lots of issues. So, another way is that mechanical arrangement. Mechanical arrangement is already I have explained during sucker rod pumping application, that you have belt drive mechanism, gear drive mechanism to reduce the speed. So, here also similar sort of mechanism will be there to reduce speed, to make it 300, 100, 200 RPM. Okay. And then you got lower RPM, then it will be the RPM or speed or torque will be transferred to your polish rod. So, in this case your sucker rod, this is called sucker rod again. Okay. Sucker rod, it is not having any tension, normally it will not have tension force, it will be transferring torque. So, from here you are rotating and it will be transferring torque to your pump is here at the bottom. Okay. So, on the surface you have all the drive mechanism, stuffing box, you have polish rod, on the bottom nearby the perforation area you have pump. Okay. And how you are transferring power? Using one sucker rod. This sucker rod is having torque and shearing action will be there, but in SRPs, SRP or beam pump, there use sucker rod. That rod actually have tensile force, but here it is getting shear force because it is transferring torque. Okay. So, that is why this sucker rod should be metallic. If you want to use non-metallic, it will be very difficult to handle because non-metallic will not be able to handle the shear force. Okay. But in sucker rod pump, you can use non-metallic also. If you have high tensile strength, anything you can use for SRP or beam pumping application. But PCP application, normally the rod will be metal bend and it will have torque, it will be transferring torque. Okay. And when it is transferring torque, basically it will be having shearing action, torque will give shear force. Okay. And when the rod is going from surface to the tubing, surface to the pump, so there will be lots of centralizer. Why centralizer will be required? You see, you have well bore, you see the picture left side. Okay. You have tubing and you put lots of centralizer. Centralizer, what will do? If rod is getting bent by because of any reason, it will not allow the rod to touch the tubing. So, tubing will not have any friction. Okay. So, that centralizer will be aligning at the center. Then pump will have its rotor and stator mechanism. Okay. So, another pump I have taken from PCM website. So, this pump says like from vertical top to bottom how the systems are arranged. First electrical motor is there, gear reducer. So, again they are using directly gear reducer. Gear reducer I will explain later. Actually, I have already explained during your SRP course. So, SRP lecture, sucker rod pump lecture. So, you please look at that gear reducer, how does it work, gearbox and this reduction mechanism. Okay. Then whole shaft will be moving to this pumping area. You can see this rotor. Rotor is normally will be drawing like this. Okay. Rotor normally will be drawing like this. Although it is three dimensionally, we cannot draw in two dimensional your sheet or screen. It is actually three dimensional. But if you see, close one eye and see this one, it will be looking like this one. Okay, like a helical shape. Now, next is experiment. This picture I have shown you several times. This is our PCP setup, actually progressive cavity pump setup. So, we have one motor here, horizontally placed actually instead of putting vertically. We have one motor, we have one motor guard, and bearing arrangement, gear arrangement, so that we can reduce the speed to 300 rpm. This is okay, this is not good, this is gearing arrangement to reduce speed. Then we have guard. Why you have put guard? Because this is high rotating machinery. So, just to protect people working there, just we put one metallic frame actually. Then there will be one connecting rod. Connecting rod or coupling. I will explain later this what is coupling or connecting rod or coupling. Okay. Then we will have pump. Okay. Then pump will be delivering fluid and suction is here. This is suction, this is delivery. Okay. Now, what happens if you want to draw a characteristic curve? First you have to draw H and Q. You can remember centrifugal pump and SRP, there also I have explained this one, flow rate and head or pressure development. So, the curve will be vertical. Okay. We are assuming no, if no leakage is there, then this curve will be completely vertical. But if some leakage is there because of high pressure creation, let us say exit valve, gate valve is there. Okay, gate valve is there. Gate valve you are closing almost completely. So, you are actually very high pressure will be developed during pumping operation. So, that high pressure when you are creating, the fluid will be leaking back. Okay, leaking back towards inlet. So, then that time actually your actual flow rate will get lower, will be lower. So, your flow rate will be lower with pressure. Okay, with Okay. Ideally elastomeric PCP or conventional PCP will have no leakage. Why no leakage is there? The stator inside there will be elastomeric layer. Okay. So, elastomeric layer softer material. Okay, elastomeric layer. So, plastic you cannot use, you have to use elastomer sort of high strength material where elastomer will get depressed. So, this rotor diameter will be little bit larger, this diameter will be lower. So, if this is D, this will be D minus delta, okay, some smaller diameter. So, whenever you are inserting, so that elastomer will get little bit depressed. When little bit depressed, what is happening? This is my rotor and this is elastomer. So, it will be depressed and high pressure here, low pressure here, one side high pressure, one pressure low pressure, high pressure fluid, this high pressure fluid, let us say this side, and low pressure here. So, when high pressure fluid touching this one, so it will not be able to pass through this gap. Okay, there is no gap actually, because this is already depressed, this is softer material, right, this is already depressed. Okay. So, fluid is trying to pass, but it will not be able to crossing. So, ideally it will have zero leakage, but if I have very high pressure, so what will happen? Let us say I have elastomer like this is metal, okay, and this is my elastomer and this is my rotor, okay, this is my rotor, and this is, let us say elastomer rotor making zero clearance, means rotor and elastomer just touching, okay, zero clearance, there is no diameter change. Okay. Now, this is P high, P low. Okay, so high pressure will try to depress elastomer. How? This is okay, high pressure will try to depress little bit and it will be leaking out. Okay. So, but if you have interference fit also, let us say initially your elastomer is like this and you apply very high pressure, in this case also the same thing will happen, a little bit gap will be created. Okay. Then leakage will be there. So, normally for lower pressure application, elastomeric PC should not have any leakage. So, complete your HQ curve will be completely vertical. So, this is actually positive displacement pump, right. Okay. So, PCP is a positive displacement pump, ideally there is no leakage. So, you are getting 100% volumetric efficiency, but if you are increasing pressure, so in that case elastomer will get depressed, and because of depression of elastomer your leakage will start. So, that time you will get some leakage flow down, your theoretical flow, let us say I think you can remember Menel has given theoretical flow, notation may be different, and your actual flow volumetric efficiency, theoretical. So, volumetric efficiency will be lower. Okay. So, 90, 95%, 99% volumetric efficiency possible, but very low volumetric efficiency may not be possible. Again each stage, so normally one pitch of stator is called one stage of PCP. Okay. So, one stage PCP will have how much pressure you can give. So, based on this will be depending based on how much clearance you are giving, what type of material you are using for elastomer, and if you create very high pressure, then leakage will start. So, normal thumb rule will be there like 75 psi, 75 psi per stage. Okay. You can use this thumb rule if no data is given. So, 75 psi per stage will be created. Per stage means one stage pitch. Now, you want to increase the pressure to, let us say 100 bar, 1000 psi. So, what will do? How many stages, how long the PCP will be there? So, this is let us say 4 inch for example. So, one stage 4 inch. So, 1000 stage you want, okay, 1000 stage per stage 75. So, 75 you divide, approximately 12 stages will be required. And what will be the length of the PCP? Length, like say if it is 4 inch, so 12 into 4, so 50 inch. Okay. So, about 50 inch PCP length will be there. So, in that way you can calculate length of the PCP, you can calculate how many stages will be required. Okay. And as I already told, ideally there is no leakage, then actually single stage can develop infinity pressure, but practically because of this depression of elastomer, the pressure will be limited by, let us say, 75 psi or something. This is thumb rule. This will be depending on material and other different properties, but normally we assume this one. Okay. Okay, this whole experimental description I have given in previous lectures. Please follow that one, those lectures. Now, when you are using PCP as an artificial lift, how does it affect? Okay, so you can see this flowing pressure PWF. Okay, wellbore flowing pressure. You can remember this one, PWF, P reservoir. Okay. Now you have inflow performance relationship. This is IPR. We are assuming this is curved, and if I have very low pressure, fluid PWF is unable to produce any fluid. Let us say initial condition is this one, PWF high. So, PWF high means it will not give enough flow rate. Why? Or it will not give any production. Why? Because this drawdown equals PR minus PWF. Okay. So, if drawdown is very low, if it is low, then no flow, right. If it is very high, means higher production rate. Okay. Now, PR normally reservoir pressure is fixed. So, flowing pressure, if you are reducing, if you reduce flowing pressure, then your drawdown will be increasing. Okay. Drawdown when increasing, more fluid will be entering into your wellbore. Okay. Now, how to reduce PWF? So, to reduce PWF, what will happen is initially you have fluid column here. Okay. Using PCP, you remove that fluid. Okay. PCP or any artificial lift, actually you remove the fluid. So, when you remove the fluid, what happens, this PWF actually H rho G, H reduced, when H reduced, PWF reduced. So, more fluid will be entering into your wellbore. So, what you do, using PCP, reduce this one. Okay. Del P pump is here, it is written. Okay. So, this pump, this energy pump is supplying actually, this pump removing the fluid. Okay. Because of removal of fluid, your PWF reduced, drawdown increased, more fluid will be entering and you will get more production. Okay. So, this way this IPR curve is related to your artificial lifting systems. Now, sizing. I already said like PCP speed will be like 500 around, here they have given on 600 also, but normally you will not find PCP more than 600. Okay. And I have taken this one from Moino pump. Okay. From their website I have taken this data, and if you see there's different models they have, and if you see flow rate, maximum flow rate, okay, for 0 bar. So, 0 bar means when there is no pressure, your flow rate is increasing. Okay. Now, differential pressure in pump 24 bar and RPM is 600. Okay. Now, different many other types of models are there. So, just to show how this pressure and your speed is linked. Okay. Next thing is that RPM, if you increase, let us say increase RPM 5 to 300 to 600. So, your flow rate will get doubled actually. RPM becomes 2 times Q, or flow rate becomes double. Okay. Because number of cavities, increasing. Okay. 1 cavity, 2 cavity, 3 cavity, increase number of RPM. So, your number of cavity transfer also will be increasing. So, flow rate also will get doubled. So, you are assuming there is no leakage. So, if leakage is there, same amount of leakage is there. So, approximately it will be double. Okay. Now, viscosity effect. For PCP is designed for higher viscosity, but and if you have lower viscosity, then story will be different. I will explain later. Okay. So, Dr. Minnals, I have taken from Dr. Minnals, I will bring this model, I will show you. We have this rotor, okay, helical rotor, and this is actually stator. Stator means like this, and inside cavity is there. So, he is not showing the cavity, and there is one joint, pin joint. This is called coupling. Why coupling should be there? Coupling should be there because you see this one. Rotate it. Okay, you rotate it. What you are seeing? Your rotor, the center axis is moving, rotating and moving also. If you see, it is moving also. Okay, you see, rotor central axis also moving. If you see, this one is moving, right? It is moving like this, central axis. When central axis moving and you have motor, let us say I have one fixed motor here, okay, motor, okay, motor is fixed here. Now I have one pump is having my helical rotor, okay. So, rotor end must be connected to motor shaft, okay. Now I have fixed motor shaft, okay. Motor shaft is rotating, but it is not moving like this, okay. But this shaft is moving when it is rotating plus it is moving like this by motor, but motor shaft is not moving. So, that means what is happening, this end will be, if I have one connecting shaft in between motor and this rotor. Rotor means PCP rotor, motor also will have one rotor. So, I am not talking about this motor rotor, I am saying this PCP rotor. So, PCP rotor rotating and moving like this, motor another end, it is rotating only, okay, it is not moving like this. So, what is happening, this is rotating and moving, okay. So, this end must be fixed and this will be like this, this will be moving, okay. That means, if we fix it properly, let us say make welding or nut bolt something, then it will get broken because it is moving, one end is moving, another end is not moving, okay. That means, you have to give some flexibility here, so that when it is rotating, it moving like this, okay, it will move like this, okay. So, for that we have different option, for example, this one I have taken from Wikimedia, this is called cardan joint. So, how does it look like? It is like this, okay. If I fix these two, okay, and my hand is, one hand is here and another hand is here, okay, these two are fixed, okay, black one and red one, okay, and if one is rotating, okay, it will make certain angle, but both can rotate, okay. So, now I have two such system. I will draw one picture here and another okay. So, see this one, okay, this is also cardan joint. Now, I will have here another, okay. So, this one here I will have another, okay, you can draw properly. So, okay. So, both can be rotating, but one can both can make angle, okay, rotating, but both can make angle. Okay. So, this way you can give flexibility to the shaft, so that one end is fixed, another is moving, although rotating and giving sliding motion also. So, then this will not create extra force to your rotor. Okay. So, there are ES PCP and other PCP, they are using this sort of joint, otherwise it will fail. And there are some gear sort of mechanism also there, but this is the most commonly used universal. This is called universal joint. So, one end there will be pin, another will be pin when you are rotating. So, just it will be moving smoothly, there will be no extra force coming into your motor or extra force going into your PCP. Okay.